So if you try to breathe on it, you'll be... And now we have Aries. That sounds like Ceres, but is not Siri. And it's kind of boring. It's white, but nobody really cares about it. I mean, it's there. But can I talk about one thing that is very crazy? Mm-hmm. All of the dwarf planets have no... Oh, that was the last thing. It was not perfect gravity. It was a rounded or like a neutralized rotation or revolution around the sun. Mm-hmm. The dwarf planets can go like this around the sun, or they can go like this around the sun. And it is random. Like Pluto, and Pluto, it takes about 245 years for it to revolve around the sun.
Wow.
Yikes, that's a long time.
Yeah.
Pluto gets a birthday in 245 years. Dang.
Wow, it's very far away from the sun. Mm-hmm. That's why.
Mm-hmm. Oh, and Pluto also has two color codes.
So is there an end to the solar system? I mean, how big is it? How big is the, well, not solar system, like your entire thing? Yeah. Is there an end to it?
I mean, it's so... I mean, there's even these things called the multiverses, the omniverses, but those are theoretical and hypothetical. And
okay, listen. All this, yes, I get it. Please, convert back to Logan B.
Okay, I won't break your brains today, but...
No,
but if,
break the brains.
Okay, fine, I'll break your brains and I'll make... And I'll put them in the pot. So... If you were to see the universe, it would look like a cobweb, a purple cobweb, a pinkish purple cobweb. Oh, and we also had a spacecraft that died, and in 45 years, it made its way out of the solar system. Crazy. And just for you to...
Wait, we had a what that died? What?
A spacecraft that died.
A spacecraft?
Yeah, and it
what do you
just...
mean a spacecraft
and it got out,
that died?
It died and it couldn't be it couldn't be brought back to Earth, and
they call it died, or it
ran out of batteries and stuff, and we couldn't...
It crashed.
Yeah,
no, it didn't crash.
You could say it like
anything.
That.
I see what you're saying.
We just couldn't get it anymore.
It's like my phone died.
Yeah,
okay.
Okay. Yeah, and we couldn't control it, and it made it.
And there was no human in it.
Yeah, and it actually made it. It made its way out of the solar system.
And ended up where? Well,
we don't know where it is.
In a different system.
No, it's probably just drifting through the Milky Way. Anyways, hey, I'm not the one who named it. Now, let's see. Dang, these names are actually very real. We have the Milky Way, and then we have Uranus. Okay, now that we're done with those, let's talk about the actual fun stuff. So, I'm gonna start from small to big. So first, we have brown dwarfs that are actually Jupiter was very close to becoming our own sun. It had the right heat. It almost had the right size. A brown dwarf is basically a failed star. It looks like Jupiter, but it's way bigger. 5 times the size of Jupiter. Almost the way it's to be a sun, but not quite.
You said a brown dwarf? A brown
dwarf. It's a gas giant, but it couldn't make its way up to being a sun, a star. And
it's
now...
not a planet.
Yeah, it is a planet. It is a planet.
What's the name of it?
A brown dwarf.
It's one of the dwarf planets.
No. A brown dwarf is a ginormous planet that was almost on its way. Was almost...
On its way
almost on its way to be a star.
Okay.
Because...
And which planet is that close to?
It's about a few light years away.
Close to which planet? Jupiter?
No, it's not in our solar system.
Oh.
But I don't think it's... Yeah, it's a few light years away.
Okay, it's not in our solar system.
Yeah,
okay.
yeah. I'm going out of the solar system now.
Okay.
Oh, and in the middle...
Why are you going out of the solar system? We want you to talk about Earth.
We're done with those because I just wanted to get to the fun stuff now.
Okay, go ahead.
We have this thing... Now there's this thing called a white dwarf. But let me backtrack to the sun real quick. The sun, it has these things called solar flares that it can, like Mercury's getting a beating. Anyways, it also has these certain chemicals that it needs to have in order to be a star. And they're bouncing and clashing together. And it's kind of like repelling and stuff. But once they stick, and like, the sun rapidly expands, and it will get rid of all of the planets in the solar system. It might just miss Earth by a bit, but even if it did, the Earth would become totally fried in milliseconds. Hundreds of seconds. Excuse me. Anyways. Dang.
It's not gonna. Hey.
We just need some.
But we need, it's getting.
Anyways, we have. Hold on, let me turn these on because we're not.
No, why?
Okay,
fine.
Okay, fine.
Okay.
It will swallow.
Okay, I'm kind of lost. Remind me again what you're talking about.
I'm talking about the sun of how in about 4.5 or 6 billion years, it will become a red dwarf and become it's super massive.
Our sun?
Yes, our sun in about 5.
It will become a red dwarf.
Yes, and it will expand rapidly, and it will also almost swallow all the way up to Jupiter. And it might
it's gonna kill everybody on Earth.
Yep.
Okay.
And that's gonna be in 4.5 billion years. So don't worry, you're gonna be fine. Well, you're gonna be dead.
Well,
you're gonna be fine.
If I live to 5 billion years, maybe not, right?
Mom, you do not want to die in that excruciating pain way. You might as well die being old than that.
That's what they call the radiation.
See,
Okay.
that's good. That's good. I'm not gonna lie. He's good. And it expands rapidly, and in about a few minutes, it will start shrinking again, then rapidly expanding again, and then shrink, and then explode into a supernova.
Who came up with that theory? Oh, that's
It's not a theory.
hypothesis.
It's not a theory.
How did they discover that's what's going to happen? Or
We
that's
have
what's
spacecraft, and we also have these strong telescopes that can see light years away.
Okay.
Light. And it explodes into a supernova in a bunch of colorful colors, but it's not going to be colorful for us. Now, let's just say that. And then, but by then we're probably going to be on a different solar system.
So they have projected that the sun is going to destroy the planet.
Yeah, in 4.5 billion years. Anyways, so when that supernova happens, there's a rare chance that it could either turn into a white dwarf, a black hole, a supermassive black hole, a neutron star, or a pulsar. But let's talk about white dwarf since it's like the smallest, I think. Anyways, a white dwarf is just basically a white star, but it's dead and it has heat, but it doesn't have the heat that you think that you'll see for like a real star, a real sun. And then it's kind of boring because you put it in our solar system, we're all gonna die. It's just not that big.
So where is it? Where's the whites? Oh.
We have some few white dwarfs, few light
in our
years
solar
away.
system?
No, definitely not in our solar system. If we had one in there, we would probably be collapsing. Anyways, and now we have black holes. Black holes are very weird when it comes to space because not only they can bend light.
Turn off the car.
Not only they can bend light, but they can actually suck up anything. So if you were able to go into a black hole, you would probably it's not probably.
Where are
you're
black
not
holes?
coming out.
Where are the black holes?
We have one super. We have one.
I mean, why are you winding it up?
We have one supernova.
Unless you want to open the door.
We have a supermassive black hole at the middle of our galaxy. And it's kind of supermassive, which means that it's ginormous. That if you come in a radius of it, if you're seeing it, you're probably getting sucked in it, or you're probably looking at it as a telescope. But if you're in a